Welcome everyone for this new webinar. It's going to be a joint webinar with partners of Neotis Digital AI. So here today we're going to talk about full stack user experience from backend to front end using NeoLoad and Digital AI. So first, as you know, before we start and before we jump into the agenda and presenting who will present this webinar with us today. Just remind you that it's a webinar, which means that you don't have access to your audio, to your mic, to your and share and drop any questions with using the audio. So that's why if anything is unclear during the presentation, you have a dedicated sections in the GoToWebinar panel for the questions. So you can drop your questions there. And also just to remind you that this webinar is recorded, which means if you have to leave us for any urgent call or requests, you can do so and you will receive later on the recording links to get the video. All right, so today I am presenting this webinar with Guy Oriali from DigitalAi. So he's CTO of the QA practice of DigitalAi. In fact, it's the owner and the founder of Experitest. So it's an honor to have a Guy here with us. Hi, Guy, how are you?
Great. Hi, everyone. It's fantastic to see such a huge audience interesting in this topic. I think it's going to be very exciting.
So for today, just to remind, so my name is Henrik. Rex said I am a partner solution evangelist. I am a performance archaeologist. If you look at LinkedIn, it's just a small joke but related to our event that we organized, the PAC, that happens last month. So what do we have for our agenda? So as you can see, it's a pretty packed agenda. We have a lot of things to cover. We will start with an introduction on the current situation, the expectation of performance, how it's important. I'm pretty sure that all of you are aware of that. And then before we jump to the main idea of the content, I think it's important that we go through the evolution of the web design, of mobile design as well. It's pretty much similar. You will see that. That will have a consequence, of course, on how we measure user experience. So we can figure out how would be the best approach to measure user experience. And if you have to deal with mobile users and you have to simulate or add real devices in your test, there are a couple of challenges related to mobile. So we will go and describe them one by one. And as a gentleman reminder, of course, don't wait until the end of the test. We have to test earlier, so we're going to remind that aspect as well. And then, of course, on the last piece of this webinar, we will jump into what are the advantage of NeoLoad, of C-tests, and we will illustrate everything that we presented today through a small demo. All right, let's jump to the introduction. So as you are, so I'm currently locked down in France. So last March, we were also locked down. A lot of countries are currently locked down, and the consequence of that, obviously, is either you have access to local shops, which is pretty great, or either you don't. So a consumer, basically, if they want to buy product, they are basically using the online retailers of the market. So there were basically, you have two ways of buying products. One is you buy a product online, then you get delivered, and the other one is you buy online and then you can pick up on the store. So in both of those channels, you have, obviously, because the store were closed, most of them, there was we observed a significant increase of traffic, 37% for online consumers and 29% for the pickup stores. So of course, no surprises, we know that because due to the situation. But it was more interesting in the study that was provided by Amazon in May 2020. It's the consequence. 68% of the consumers that maybe were not used to use online platforms to buy products. They are basically continue this behavior after the COVID situation. So we expect more traffic, more load, and of course, because we all have been using mobile devices and browsers, and we all have Facebook and Instagram and others, and we used to get pretty much good response times and good user experience. So if we don't, the first thing is if we have to wait more than 3 seconds, we start to be a bit annoyed. That is true for mobile, web, and if it's even true for restaurants. If I spend too much time waiting, I get sort of frustrated as well. So our users and the consumers of our applications, they are expecting a lot of good performance. And the other dimension of the current situation is digital transformation. Any organization to survive in this digital world, they need to provide different channels, mobile channels, web channels, and others. So digital transformations was a key success, a way of surviving in this current situation. So, but behind this, because performance is important, it brings a couple of changes on the way of delivering performance. The first aspect of the change is the methodology. So 15 years ago, we were working on most of the project. Most of us were working waterfall. So 6 distinct steps: requirement design, implementation, testing, acceptance, and deployment. And usually for a performance engineer, we were usually being involved in the project between acceptance and deployment, pretty much late in the cycle. We can discover problems. Those problems usually are pretty much complicated to resolve because you need to change a lot of things in your code. We didn't have much time to do so. So basically, we were considering to go to production even if we knew that we have problems. Then we shift to incremental, no big changes. And then I think Agile is a big is pretty much positive because we are taking we are looking at our customers and we are changing depending on the feedback, which is pretty good. But performance cannot be put on late on the cycle or just on the hard-doing sprint anymore. You have to implement it as early as possible. So you have to change the way you deliver performance, and I think that is pretty great because it's a way of putting more importance in performance in general. The other aspect is obviously the architecture. The architecture that we are building as of now could not be compared anymore to the application we used to build 10 years ago. Most of the time we were building those monolithic applications with 3 tiers: presentation layer, business layer, and database. We were basically building and compiling the entire logic if you look at the business layer. So a big binary file, and then we were deploying it on one server that will have everything there. And we would do some capacity planning to figure out how many nodes we need to have to handle the load. But there was no way of putting more power to one specific service of our organization because we had to deploy on the entire stack. So that is not pretty much very aligned with the scaling. And we were able to scale, but we were consuming quite a lot of resources at that time. I think now by shifting to microservices, it's better in that sense. Where just to remind you, so every the small portion of the application, small portion of the business logic will be split into the services, and a small team of dev could handle one service and lead that service. They have their own pipeline. They could have their own language if they want, their own database, their own storage. And then if the pipeline is successful, then output you deliver a container, and then that container will be used to deploy the entire stack. But one thing which is pretty good is that if you need more extra power just for the service A, you don't need to deploy everything anymore. You can just deploy one more nodes for the service A and to handle the load and avoid any crash. So I think it's pretty good. And without a sense of design, you can move to the cloud because you have all the advantage of the cloud. So, and if you look at the marketing messages of the cloud, it says, "Oh, we're gonna reduce cost. It's pretty amazing. We're we're going to be increase the fact that we're more available, and it's going to be simplified. It's going to be modernized, but in fact, it's not so true. It's true, but the problem, if you deploy bad app in production, which is consuming a lot of resources, the consequence is that you will need more nodes to handle a load, and if more nodes means more units that you are spin up in your cloud provider, so more expensive your environment would be in your production environment. So you need to be controlling the costs. So performance is not only about response times, it's also about costs of your environment. The thing is, so now we've seen the importance of performance in the way we're designing our applications, and now let's look at how the web design has changed. So here, basically, the left side, it's Amazon.com in the, I think it was in 2000 something, and on the right side you can see Amazon.com, the screenshot we're taking last year, I think, something like this, for the French websites. Obviously, we can see that it doesn't look the same at all. I'm not saying that in 2000 we were having bad design. It was pretty good at the time. It's just that the way we're building websites have significantly changed. We're trying to provide more user experience to our user, and the consequence of that is I just did an extraction on HTTP archive. So if you want to see some statistics about the consumption of web application, you can go to the websites. And you can see here, basically the size of our websites has significantly increased last years. And we are all now, I think we are almost reached 3 megs, which is ridiculous. But we have all got pretty good connections, so we don't see that. Also, the number of requests just to load, it's just impressive. I mean, Amazon.com is like 200 requests just to load the main page. It's impressive. So basically, we are moved the way where everything was the logic of our apps were sitting on the server side. We have changed that, and we're pretty much mimicking the way of the behavior of a mobile device as well, where you have a native app, and then native app has more part of the logic. And it's the same thing. So basically, we request the websites, we get the website itself, we get the JavaScript and all the JavaScript, and then you have all the logic there. And the only thing that the client will do is basically send some AJAX requests to get some content back, and there we can do basically the JavaScript would do the rendering on our client. So the consequence, of course, if we do that, is the JavaScript, the size of our JavaScript pages are just has exploded the last few years. So I'm not going to drill down on all the how the rendering works, but basically, when you have a client and you have a lot of AJAX calls, you send a request to get the payload, the JSON content, and then JavaScript comes in the picture and then process, and we'll do some changing on the DOM. So the browser needs to understand the structure of the DOM, will process. Once he has the real structure, he could basically start rendering. So this is a real mechanism that happens on the browser. And if you're just basically measuring the time to send a request and get a response, you don't include that processing time, which could be very significant on a client side for sure. So that brings the fact that we need to measure differently our user experience. And I think, there's a problem with the animation, but all right. So let's describe what happens behind. So basically, here I have a small story saying that once upon a time there was a project that needs to simulate 5,000 user primarily reaching out from the mobile devices. So print functional came into the meeting and say, all right, the best way to do it is, because we have so much things happening on the client side, we're going to basically generate the load from real devices and real browsers. Excellent idea. So everyone agreed. They run the tests. They spin up 5,000 grids, same grids, for every time they were executing a test automation script. And the load test will take about 2 to 3 hours, depending on the ramp up. The consequence of that, first of all, pretty much complex to have a robust scripts working. The second aspect is the costs. Having 5,000 concurrent devices running for 3 hours, you can expect some significant cost out of that. So the project leader, Donald Duck here, was not very happy because basically they consumed a significant cost to generate the expected load. So they basically, there's two dimensions here. We in the load testing industry, there's the protocol level testing and there's the browser-based testing. Protocol level testing is pretty good in a sense, which is pretty light. We used to do it a couple of years back, but the problem is that the response time that we're getting, it will never include the rendering time. So I would say it's low cost, but we don't have the full picture of the response time. On the other side, you have browser-based testing, more realistic because you drive the real device or your browser. The first thing is custom maintenance. Scripting could be, to make a robust script could be quite painful. And also the other aspect is the hardware required to generate the load. I mean, it's nothing to compare to protocol. So if you want to have a decent solution, don't go for 100% browser or 100% protocol, because if you want to have a good balance between what you want to measure and how you want to measure it, the best, I think, is to have a hybrid approach where you do protocol based and then you have real devices that will report user experience. So now we get the idea how to measure response times. But here we were talking a lot about devices and browsers and so on, and we have a lot of people here using mobile devices to reach out to websites. So what are the main challenges of mobile? Guy, could you walk through those different challenges there?
Sure. So in a lot of sense, mobile application are very similar to web application in the way they consume the data from the server. So you will see a very similar mechanism of authentication, REST API, and such, but on other aspects, there are huge differences. And let's go to the next slide. So the first and most important part is the communication layer or the network that and this is something that you could see also today due to the COVID. Depend on the country you are from, but the infrastructure as you're working from home is really very loaded, and in some cases you will experience the same as on mobile, also on your desktop when you're using your home network. But in general, the infrastructure in order to serve your mobile device include some cellular communication that introduce packet loss and latency, and then a few hops of communication, and so it's very different than the communication or the network when it's come to an enterprise network. So it introduced the packet loss that have a huge impact on the throughput of the communication and to the latency of the data transmitted. Let's go to the next slide. And so here you can see some research that was done, I think, by an engineer from Google, and obviously the most important part that impacting your traffic when it comes to desktop are latency and bandwidth. The amount of packet loss is relatively neglected, but this is not the case when we're talking about mobile. When we're talking about mobile, due to the last mile, the wireless connection into the cellular, into the cell antenna, usually can and will create packet loss. And packet loss has, especially on the TCP protocol, it has a huge impact. The way the TCP protocol works is there is a concept of window size. So you need to get an acknowledge for the data that you are sending in the size of the window size. The way TCP works is whenever there is a packet loss, the window size is cut to half, and then it will slowly go back to the maximum value. So, but what it causes is that it's very sensitive to packet loss, and packet loss will reduce dramatically the bandwidth of your communication. Let's go to the next slide. So this is an interesting story from 1998. I was working for a company here in Israel, a startup that was selling broadband equipment to Reliance in India, and Reliance has a fiber optic, a big hole that goes through the entire state of India, and it is 10,000 kilometers long, this fiber optic, and we got complaint from the customer that the latency around this fiber using our equipment is 50 milliseconds. Now, 50 milliseconds, it's quite a lot of latency when it's come to network equipment. So I packed my bag and I flew to India. It was my first time in India, in Mumbai, and we tried to analyze this problem, why we are getting this latency. After 2 weeks of work, what we've discovered is that this is a simple physics. If you take the distance of 10,000 kilometers and you are dividing it by the speed of light inside the fiber optic, you will get this 50 millisecond. What happened for me as an individual, the fact of latency become something that is more realistic. So if you are in India, if you want to communicate with a server in the US, it will take you around 150 milliseconds due to the nature of the distance. Nothing can shorten those times. So this is latency. Packet loss and the throughput are also something that you should have the sense and feel what it means. Let's go to the next slide. So, and when it comes to transmitting data over HTTP communication, which is most of the communication today, you will find things like DNS lookup, an SSL handshake, and this is a regular breakdown of every communication that goes out, and each part, like the send request, the waiting for response, each part of that can have some issues. And let's go to the next slide, where we can see how a typical scenario of when you enter into your browser a URL, let's say you are browsing to CNN.com, the first thing that will happen is that you need to resolve the URL into an IP address, and for that you would use the DNS server. In some cases, resolving the address can introduce some latency. Once you have the IP address, you will open a TCP connection, and this is a three-part handshake. You send a SYN packet, you are getting a SYN acknowledge, and then you are setting an acknowledge, and then on top of that, you are starting the SSL handshake. And only when this connection, the SSL handshake finish, the connection is established, and you can send the HTTP request for the CNN.com, getting the content of the index, and then analyzing the index and start to downloading all the resources in order to serve this page. If you have a proxy, it's even more challenging and complex, and I will not go into the proxy scenario, but you can see that it had some more complexity around the way it works. Let's go to the next slide.
Yeah, important thing is that this latency that you describe will be added on every single small communication you see in this diagram, which so you mentioned 50 milliseconds or 150 milliseconds. It means like, wow, if you have maybe 20 different requests going back and forth, it's like 20 times 50 milliseconds, which is going to be quite significant in terms of response times.
Yeah, so the round trip that you will have a huge impact. So even as a user, 50 or 100 millisecond is not, it's a fraction of a second, tenths of a second. It doesn't sound much, but what you need to understand is just to open the handshake, you need to do a few round trips. And if you have communication or API calls that are based one on top of the other, or you have a limitation to the amount of parallelization that you have, and it results in a lot of round trips. So every 100 millisecond can be translated into a few seconds of serving a certain page. So this is an example of a smaller amount of client-server round trip. In the next slide, you can see that if you have multiple round trips, then the user experience start to be very painful. And adding to that, when you are serving a large amount of user, there will be a huge load on the server, and all those requests will be piled up in the server, and it will create a huge load of concurrency on on the server itself, because there will be more user, and as they are being served slower, then the amount of concurrency is growing and impacting the user experience even more. So this problem is not stabilizing itself, it's getting worse as the load is higher. Okay, this is just the waterfall view, a breakdown of communication. And here you can see that this is just a simple, a navigation to a website. So you can see that first you get the redirection, and then you download the index HTML with its content, and then you can start to see a level of parallelization where content is being downloaded, but you can see that there is at least 3 or 4 round trips until the full page is being rendered. And the good part about mobile is that you have much fewer requests, because it doesn't. Web pages are based on some infrastructure packaging, and that create a huge amount of requests. Usually for mobile, this is not the case. You will see much fewer requests because those are being handled manually or being developed by the developer themselves, and not due to a framework like WordPress, that is a plugin of WordPress that are generating a huge amount of requests. So a regular website, you can see a few hundreds of such a request. Let's go to the next slide. Now, a very important concept to be aware of is speed index. It's a client-side measurement or metrics that measure the user experience around loading of a page, either web or mobile. It's a visual indication, so it doesn't care about the technology. And to better understand speed index, you can see here 2 examples. Both examples are web pages that are getting loaded in 5 seconds. On the top, you can see that for 4 seconds you don't see anything, and in the 5th second, the entire web page is being loaded. on the lower example, you can see that even after the third second, most of the content is being served. And then on the fourth and fifth seconds, just a few more topics are being, or content is being loaded into the web page. Obviously, the duration in both cases are the same, but the user experience is hugely, it's a huge difference in the user experience. So obviously, duration is not a good enough metric, and speed index is much better due to the fact that it takes into account what the user can actually see. And the way it works, it takes the last image of the web page or the application that you are loading, and it comparing it back to all the entire video stream. So based on the video stream from the device or the browser that you are using. Going to the next slide, you can see how it is being calculated. So speed index is the graph on top of this percentage, pixel percentage. So, on after 5 seconds, both of the pages are fully loaded. So they have 100% pixel comparison accuracy. What you can see is after 3 seconds, in one example, we are at 90 or 80%, and in the second example, we are at 10%. So this is, and so you can see that the area on top of the graph is smaller in the second example I've shown, and this is the way you want it to be. Let's go to the next slide. Okay, so so a few guidelines and recommendation. And this is something that it's very, very important. And this is related to what Henrik said in the beginning. You need to connect performance into your pipeline. And what it means is whenever you build a service or a solution, as you are running your unit test and as you are running your integration or system test, you do want to start running your performance test to different level. It can be a benchmarking type of testing, or it can be you can create what we call a baseline. In the previous version, this is how it performed. I just want to see that it doesn't introduce any regressions, but it is very important to test your performance as part of your pipeline, and this is the essence of what you need to do in order to meet the agile and DevOps type of development. Let's go to the next slide.
In fact, so here, as Guy has explained, and I tried to explain it at the beginning as well. So if you're having a mobile app or if you have a browser app, from the design perspective now, all of the UI is based heavily on REST calls or maybe WebSocket. So, which means you don't have to wait until the UI is ready. Usually, you got the REST available, the APIs. So to be able to achieve your realistic tests, first of all, I want to do automation, secure my releases. So before I do anything, I need to understand how my system is being used. So having something that monitor that brings back the usage, how my application is used by my user, will be critical on my testing approach. So I need to understand which scenario are being utilized at what time, what are the user constraints, the user locations, everything that will help me to have a realistic simulation. Load testing, remember, is a simulation. So if you do the wrong simulation, then you will probably have non-interesting metrics, and the test that you're doing doesn't bring value for your teams. The second aspect, like I mentioned, everything is based, you don't have to wait until the building is assembled on the left side. You know that your building is based on bricks. So we know that our mobile apps, we know that our browsers are based on REST calls. So why should I wait until I got the UI to start testing? No, I don't want to. From the moment I got an API, it means I can already start. Of course, I'm not going to test everything, all the APIs that is available in my app, because this is going to be ridiculous in terms of building and setting up all the automation. But I'm going to basically focus my effort based on the risks. So testing the heart, the brain, the eyes, the hands, the legs of my app on day-to-day basis. And to do that, we're going to implement what we call continuous performance testing. So from the dev perspective, I'm going to test the API, and I'm going to apply the same load for each build. We're fishing for regression here. We're not fishing for anything else. If I see that I have an API that behaves differently from the previous release, I know there's been a regression introduced by a commit by a developer. Then I move on to integration, and we just talked a lot about network. And by integrating, I will have different components, different APIs that will probably sit on different servers on different nodes. So I have distance, I have latency introduced. So integration is highly critical because you can basically discover a lot of performance defects just because you introduce the distance. And of course, traditional end-to-end testing, we used to know that testing real devices, real applications makes sense as well. The way we're going to analyze here, and because we are fishing for automation, most of the organization, they are doing manual analysis, and but it's still possible to do automated analysis. And let's take a few seconds and figure out how you do the analysis. So manually, if I do analysis, I get a load test. I'm going to look at the user ramp up, and I'm going to make sure that my hit per seconds or request per seconds or the throughput is basically following the ramp up. If it don't, I'm pretty facing some issues there. Then I'm going to look at the error rates as well. If I have too much errors, I may think that my script is not robust. I may think maybe my data set doesn't make sense. So I have to resolve them. And if there is a real application errors, I have to figure out why I'm getting those errors, because it could be real, an interesting inputs for potential bugs. And then if everything goes well, I would jump to the response times. The response times have spikes. I understand why I got spikes. And I will, in any case, I have to check on the resources, how my architecture is behaving. Is it healthy or not? Because it doesn't make sense to deploy an app which is responsive, but my infrastructure is suffering on the background. So to do that, we're going to introduce the notion of quality gate. This is something I'm pushing heavily. Quality gate will be a component, a step in your pipeline that will basically validate the status of your tests. And it's based on SREs, site reliability engineering. So the idea is we have to define our indicators, SLIs, service level indicators. We will describe each individual indicator. So it could be response times, it could be CPU, it could be memory, it could be per second, or whatever you want. And then we will, in front of those indicators, I need to define my objectives. It could be based on the thresholds, it could be based on comparison, or both. And the idea is that based on the objectives, I will basically figure out if I reach out my objective or not, and I will get a score out of it. So basically, the quality gate at the end in your pipeline, he will reach out to your specifications, the SLIs, the SLOs. He will reach out to the various data source. So data source could be NeoLoad, it could be also Experitest, because Experitest has tons of indicators. It could be a Dynatrace, it could be Prometheus. So he will basically collect the various values of each individual indicators that we specified, and then he will check out if we have reached or not the objectives. And based on that, he will calculate the score. So I mentioned scoring at the beginning. Scoring could be achieved by this way, and we'll put an SLI on the score itself. So, Guy, you have few best practices here. Could you share your tip?
Yeah. I want to touch on what we call transaction matrix, the part that you need to monitor, specifically in mobile, and to compare between versions. So, you know, one of my favorite approach is to create a baseline. and to be able to compare any new version with the previous version based on that baseline. So the first indication is the duration. This is the most common, and as I mentioned, speed index is a better one. It's more complex to calculate, but first of all is the duration. And when we talk about transaction, just to explain what is transaction, every time you are performing an operation, clicking on a button on the UI, performing a search, performing a login, this is what we define as a transaction. And the transaction starts when the user click on the button on the mobile device, and it ends when the device stop rendering the result. So duration is one, CPU and battery is very important. And just one comment about transaction, you want to measure each transaction by itself. The login transaction is one transaction, the search, the payment, so usually you will have a few hundreds of transactions in a single application. So we talk about duration and speed index, CPU and battery, amount of API calls. So you do want to minimize the amount of API calls. Then you need to monitor the download data in each transaction, and you want to minimize this data. And finally, you want to monitor the amount of time the request is being held by the server itself. So usually it will hide a huge amount of layers of business logic database after that. But you can see that there are two types of or a few types of metrics. Some inclusive, some are client side, and some of them are server side. And you should be familiar with all of them. Going to the next slide. A few tips. So the first one, when we talk about client user experience, what I found that is something that you should do when you run your functional testing using anything like Appium or whatever. Don't do it in a Wi-Fi best condition. Use network virtualization to simulate bad network condition, and do it in 3G average or 3G bad, because the difference between 3G and Wi-Fi in your application is huge. So you are testing a different application if you are testing it in 3G or if you are testing it in Wi-Fi. And the reason that you will release an application and you will think, wow, this is a great application, and your customer will tell you, and when I mean they will tell you it's in the App Store, they will just mark it as one-star application. Usually it will due to the different network condition under test. The second recommendation is, as I said earlier, to create a baseline and to know what you expect in each of your transactions. Let's go next. Okay.
So let's figure out the so I'm looking at the time, so I'm going to go very brief on the advantage of NeoLoad, and then we can go on C-test and then jump to a very short demo because we are running out of time. So basically NeoLoad, for those not aware, we are load testing softwares in the market since 15 years, and if we have to just think about the core advantage of our product is productivity. If you look at every feedback that we're receiving and testimonial we have on our websites, everyone's saying that they're saved 60, 70% of the time. In terms of technology, we support, of course, all the latest technology of the markets in terms of modern web architecture, but we also support package enterprise solutions like Citrix, like SAP, Oracle, and all the new package apps flavors that comes on the market. We can generate the load from the cloud, on-prem, and we have tons of integrations, so we can connect our tool to various platforms. The way the architecture of our solution works is we have in the middle the web. The web could be SaaS, it could be on-prem. The web basically would be the central orchestrator. He will spin up the right infrastructure for your test controllers and load generators, could be on-prem, on cloud. And we have a dynamic infrastructure feature that connects to Kubernetes and do the manage your infrastructure for you without any extra configurations. But the good thing with the web is that we do everything, and there's tons of API, and the API allow us to grab data from a third-party product, connect to an APM product, to be interacted but with any CI server of the market. In terms of design, to build our test case, we have obviously two different needs. I want to test as early as possible, managed by dev teams. So here, I will probably want to use more a tool, a format or language that will be more compliant for dev personas. So here, YAML description language, for example, JUnit libraries. But then if you are later on the cycle, I am pretty much interested to be able to record traffic. So the UI, the GUI product that we have will record the traffic, will support SAP, Citrix, you will do complex design with it. It makes your life easier because it's a GUI-based product. But at the end of the day, it's not two different tools, it's not two different standards, it's one same tool. So there's a real collaboration. So dev could build some few test cases. Then later on, if I'm not technical guy, tester or performance, still reopen the work done by my colleague and reuse it. So collaboration is really crucial for us. In terms of applying load, especially on the user experience and everything that we talked today, we are protocol based. So if I want to generate load against a mobile device or a web device or websites, I will do it through NeoLoad on the protocol level. I will be able to apply the network constraint that we described, latency, packet loss, bandwidth limitation, and so on. And so 99% or 98% of the load will come from our protocol. Will require less infrastructure. And then on top of that, I will spin up a couple of devices. So I will basically integrate with C-Test, and C-Test will be there to drive a real use case scenario by clicking on the screen on the browser and report back user experience. The app index that the speed index that Guy was referring, it will be available in C-Test. So you will have the 360 degrees vision on how your performance is behaving. What about the C-Test?
Okay, so I will go really briefly on because I do want to have some time on the demo. So DigitalAi is a solution in the value stream management. It is a collaboration of 5 companies, CollabNet and Version1, that do agile planning for enterprises, then Arxon that are doing security and application protection, as well as security testing. Then we have Xibia Labs that are expert in DevOps and the deployment orchestration. And you have Expertise that manage devices and browser. We do that from 8 data centers around the globe, and we provide you real mobile physical devices as well as browser. On top of that, we have a Numerify that do AI power analytics. So going to the next slide, you will see the a few values. So we have a unified testing environment. We support accessibility testing. You can run your test at scale, use open source infrastructure like Appium. We have a very flexible environment, and the best part of that is our performance capability that works very well with NeoLoad in the sense that we provide the client-side user experience, and together with what NeoLoad show you about the load and the server side, you get what we call the full stack performance. So you can really nail down all of your performance challenges.
So let's jump to the demo. Let me explain briefly what we have here. So today, what we have prepared here is we have on Amazon, we have a Linux box that has Jenkins installed. And Jenkins, we have a pipeline that will briefly describe the pipeline. So I want to avoid you show you a Jenkins file, but Jenkins will be basically spin up the different hardware required for the tests, and then connect to the web I mentioned before to run the test and delegate this execution. And of course, we have expiry test in the picture. It doesn't make sense to run. So here we were focused more on the end-to-end testing, where I need first to double check that everything works in a functional way. They have no regression of functional aspects. And then if I have the green light from expiry test and go through the steps further, which is running the real load test combining NeoLoad and expiry test. So the flow is the following one. So first, the code sits in GitHub. So we're gonna check out the code. We're gonna build our Selenium test. So we are the test our build on Selenium Java. We build this jar file, and then we go through the step where I say, okay, now I'm going to run the test against with the expiry test to get the feeling. I get a report back. Then once if all those steps has been validated properly, then I can move on to the load test step, where I will first deploy the load testing infrastructure. Once it's been deployed, here I'm using container, but if I don't want to use container, I can still use any infrastructure sitting somewhere else. And then I run the load test itself. And the test itself combines NeoLoad plus C-test. So let's have a look on how it looks like. So start with, I'd like to start with, first of all, the test case, the design, because of course you need to design. So let's start with the Selenium stuff. So here, this is my IDE. So if you it's IntelliJ, so this is I prefer IntelliJ, but never mind. Here we have expiry test Appium. So this is basically the Appium test case that we use for the functional validations, the first step one, and also it will be also reused by NeoLoad later on. So how does it work and how the integration works? Basically, it's very simple. In like any test, Appium or test that will be executed in expiry test, you need to have an Android or Android or iOS driver or a traditional Chrome driver, whatever. So here we're using Android driver. I'm connected to expiry tests, and then once I'm connected, I am passing back this driver that we just created into the NeoLoad web driver factory. So we have a wrapper in top of Selenium, and that will be then used to go through the various steps. So it's compatible. So this is basically the step number one, is we need to have a test case to interact with the screen on a UI level. Then in the pipeline, like I mentioned, we would go further on with load test. So what do we get, first of all, with the first step, with the, let me move Chrome here up. Here it is. So what are we getting out in terms of results back in expiry test? So first of all, I have running several tests here. There's a couple of incomplete, but if you here you can see that we have one test execution that went pretty well. So I can have access to the report. I can visualize the videos. I can visualize all the different metrics. Here we have defined key transaction, like Guy suggested. We need to define what is a transaction to get more indicators back here. So all the details just for the first execution that we're doing in our pipeline will be accessible here in this report. And I will be able to drill down, look at the various stuff. Every transaction, I can have a specific report for this particular transaction on how many CPU I've been consuming, the memory, the speed index of that specific transaction, and so on and so forth. So here, basically, without NeoLoad already, you have tons of details just in expiry test. The second step, like I said, we were going to move on to the load test. So here, I'm going to utilize NeoLoad. Oh, NeoLoad, sorry, wrong screen. Up here it is. It's here. So, oh, what's happening? Okay. So here is NeoLoad. All right, so NeoLoad, this is the NeoLoad UI. What I have here in this project is obviously I have 3 users. So we call user path. User path is like a script for us. So I have a traditional NeoLoad user path, where basically this one has been created by recording. So I've been click on record. I was able to capture the traffic from a browser. I could do it so with ACP or Citrix if I wanted. So I build the flow. I build a correlation. I import my variables. So this script or this user path is robust and ready for my test. I have 2 type of user: the browser, it's an e-commerce website, and the buyer, the one who's going to officially buy. And aside of that, I've added an extra user. And the extra user, basically what he do, he will call one of our advanced actions that we have within our product. And here because I've built a Java CM test case, I'm going to use the Java component of NeoLoad, and I'm going to ask basically NeoLoad to say, hey, every time you do an iteration in the action, so until the end of the test, please run this Java process. The Java, basically here I'm passing the expiry test jar files and passing a couple of arguments to connect to pass some data sets to expiry test Appio script, and that will make the automation. So to make that, first you need to design, you need to build those user paths. Once you have built them, you need to define what we call populations. And here I would be able also to define if I want the one emulations. Like I said, we also have one emulation from our side. We also are passing to expiry test what we call the network profile, what type of simulation I will do in expiry tests, so 3G, 4G. So then, like Guy suggested, never test in Wi-Fi, test in real conditions. This is what we do. And then the design is done, we can define our tests. So here I have one test called expiry test load webinar. And you can see that I have 2 populations. One, it will be expiry test, where I have only one same user, but if I wanted, I can spin up 4, 5, 6 users, depending on the number of devices that I have available in expiry test. And aside of that, I have my real protocol level load test. So here, most of the load will come from this user. So how do you trigger that test here? Because it's a pipeline, like I described, we have here Jenkins that runs the pipeline itself. I have a couple of runs here, but what do you get out in NeoLoad? So let me connect to NeoLoad. Here it is. And in NeoLoad, so here I get home. You can see that I have lots of different tests here, and I'm going to select one of the tests. Let's say the test number 8, whatever. So here I can see that obviously I have a couple of errors. I may have to look at the errors. I have the hit per second, the response times, and where do I see the response times coming from expiry test? So here I can jump into the dashboard. Dashboard is where you find all the metrics related to one particular test. In that dashboard, I would be able, for example, to create a new graph here, and I say I'd like to look at the homepage. Up here it is, and I'm pretty much interested in the percentile graph. I didn't get it, but let's say the average duration instead. Here it is. And so now I can look at the response times from a protocol level, not user experience, protocol level response times. But how do can I get the response times coming from the execution on real devices or real browsers that is done in expiry test? Here in the MITRE section here of NeoLoad, you will find external data. So all the data coming from an integration will be here. If I expand it, you can see that there's a Selenium folder and a couple of timers. So here I have the transaction that we have measured directly in expiry test. So I will be able to compare the time that we receive, the response time from a request level, from a protocol level, and in parallel, I will be able to compare it with what happened really from an end user perspective. So get the rendering time, the missing piece that we don't have in NeoLoad as of now. All right, so I'm not going to run any tests because I'm looking at the time. We are almost at the top of the hour, but this is what I wanted to share today with you. Guy, do you have anything else you want to add on the demo side?
No, I think this is this is a full integration that enables you to, this dashboard enables you to see both all the protocol level metrics as well as the application user experience. I'm not sure we will. I see that there are, many questions piling up. I'm not sure we will have time for question. Maybe single questions. How easy is to set up a pipeline?
So I think so. I can start, and then you can probably add. I think the pipeline really depends on what you want to achieve. I think if you look at a pipeline that is aimed for dev, of course you have to build. You have to. There's a couple of maybe a couple of unit tests there and so on. So it really depends on the process. If you're part of the build mechanism where you're going to check in, build, deploy, and run tests, there are obviously a couple of tests that needs to be done. Maybe do some what we call smoke testing, just to figure out that the environment is really up and running and being is available. It doesn't make sense to start the automation if nothing is running. But I would say that once you know how you want to structure the pipeline, it's pretty much easy. But again, it really depends what you want to achieve. I've seen a couple of customers that do only a pipeline for testing, but I think it makes more sense to have the full picture where you check out, build, deploy, and so on and so forth. Guy, do you have anything to add on here?
Yeah, I think that compared to do it yourself or different other approaches, it's relatively easy to create a pipeline and to keep it simple and do it full automated pipeline. This is the important part.
So the second question is, how do we ensure the page is completely loaded, just like the user perceives? And how does the automation suite give us the complete page load time? I believe that can only wait for some objects presence / load. It's an excellent question. I'm pretty sure that in the web, at least technology, there's an indicator called the first content painted and the last full painted. So basically, painted means it's been displayed and you can start interacting. So if you look at Amazon, you load the page, you feel that the page has been fully loaded, but it's not the case. It's the rest of the page has been currently been loading, but because it's part of the page has been loaded, then you can start interact with it. And I think this is the most important indicator. By just saying that load time everything has been loaded, it doesn't really represent the real user experience, because again, remember, you could take 10 seconds to load, but maybe in four seconds you're already able to interact with the page. So it really depends. So don't limit yourself on just on loading time.
But by the way, the speed index resolves the certainty of when the page was loaded, because even if you will take a larger video of the transaction, everything that if the page was already loaded and you were waited, it will be ignored due to the nature of speed index. So this is an additional reason to use speed index.
So smoke test is really important. I would say that smoke test is always important. So if you have a load test of 30 minutes or 40 minutes, if you have automation that goes a lot of steps, it could be frustrating to wait, let's say 20 minutes or 30 minutes until your pipelines end to see that, oh, my problem is not related to my app, it's just because there's a deployment problem. So I think smoke test makes always sense to at least control that the basics on how you've been deploying the application is there. If not, you could be frustrated and quite angry on the fact that it's not a real problem, it's just a human error mistake if you don't put a smoke test.
Maybe last question. We will any question that will not be answered here, we will answer it and send the response offline. But when and how often do you recommend to run the tests? So I think that usually the ideal situation is that every time a developer is performing a pull request and merging its changes into the master, you want to run those tests as part of this pipeline.
There was one question about, I think, our driver at Neotis. Just going to add it related to the robot framework. As of now, our Selenium driver is only compatible with Java or C#. We don't have a Python driver yet, but maybe one day we will have. We have, by the way, there is a experiment that we have made. It's public. You could have a look at it. We made a specific grid of Selenium where you don't have to use this remote driver anymore. The grid would be part of the infrastructure of Selenium, and the NeoLoad grid basically will instrument lively the scripts, so it's easier. But again, when we are not using it publicly because we have some defects about it. So it's more for us like a prototype approach. But it's interesting. It's another way of doing it. So if you it could be interesting, Emmanuel, to reach out to us. We can maybe figure out if this grid will be compatible with your robot framework script. All right, so I think we have exceeded the time for sure. So I'd like to first of all thank Guy for being here with us today for this webinar. Thanks for all the content that you have built. And thank you everyone that was connected today to this webinar to follow us. And for those who didn't have the time, don't worry, you will receive a link to watch to the recorded section.
Thank you, everyone. Thank you, Henrik.
Thank you, and have a great end of the day, and see you soon.